Good morning, class. We are looking at section 8.1, the law of sines, and we've already covered a big chunk of it. We are going to move on with the rest of that. So as it was mentioned, we're going to cover the law of sines. We're going to move on to the law of cosines, polar equations. The objective is to solve various triangles. Side angle, angle, side angle, side angle. S represents a side, A represents an angle. So we looked at properties of trigonometric functions, fundamental identities. And these are fundamental identities we have seen many times before, okay? Whether we are dealing with a unit circle, sum and difference formulas, even an odd properties, the fact that trig functions are periodic functions. We look at double angle, half angle formulas. Okay. For example, sine of 2 alpha is 2 sine alpha cosine alpha. Now, cosine 2 alpha has 3 different answers: cosine squared minus sine squared, 2 cosine squared minus 1, 1 minus 2 sine squared. Right triangle, a definition of a sine, opposite over hypotenuse, cosine adjacent over hypotenuse, tan opposite over adjacent, and the rest of them are the reciprocals. Definition of angle of elevation versus depression. So you have this horizontal line, the angle of sight. If you look down would be the angle of depression, up would be the elevation. Now, bearing, there are 2 methods. One is that you just compare it to the north side and you go clockwise. Method 2 is that you go either with north or south, whatever is the closest. So for example, P1 is closest to north. So you go with north 30 degrees east, but P4 is closest to south. So you go south 20 degrees east, as an example. Oblique triangles refer to triangles whose angles, none of them is 90 degrees or right angle. Acute means it's between 0 and 90 degrees. Obtuse means it's between 90 and 180 degrees. Here's the sine law. Basically, the ratio of sine to the opposite side is the same for all vertices. A, B, C are called the vertices, and across from it, we go with the lower case, which represents the side. There are different types of triangle and cases that we try to solve. Normally, 3 pieces are given, 3 pieces are missing. There are 3 angles, 3 sides. So we have 3, we want to find the other 3. So ASA, SAA, SSA, SAS, SSS. So those, and of course, S refers to a side, A refers to an angle. In the first case, angle, side angle, or side angle, angle, one side and two angles are known. We get a unique solution. Side angle, that means two sides and an angle. It ends up with a case that we may have one solution, two solutions, or none, known as ambiguous case. Side angle, side, side. This last one, we use cosine law. And of course, this one, side SAS, that is the included angle, and this does have a solution, a unique solution. So we looked at the proof of the law of sine. So basically, in this case, we are finding the value of h in the two triangles. The left side is a right triangle, the right side is a right triangle. And we use the definition of a sine, which is the opposite over the hypotenuse. We find that. And we do the same thing here. We use a different, height or altitude. And again, we have two triangles here, the smaller one and the larger one. And ultimately, it gives rise to the sine law. And we prove it that way. This case was very simple. Side angle was given. And as I said, if the triangle is given to you, so be it. If not, you can make up one, and it may not be to scale, but at the very least, it will help you see what's going on. When two angles are given, the fastest and easiest way, obviously, is to get the third angle and then move on. Because as long as you have all the three angles, the sine law will help you get all the sides. You have the three angles, you have one side, you can find the rest. In this format, ASA, angle, side angle, the same thing. You have two angles. So find those first. Okay, so you want to find those first. That means the third missing angle, and then take it from there. Now, the ambiguous case was discussed, and what happens is that H has the value of B times sine A. If the opposite side of A, lowercase a, is less than this H, there is no solution. But if H is less than A, less than B, there are two solutions. And if it is equal to A, it's precisely one solution, which is a right triangle. So we looked at this case. Notice what happens. We go through the process because two sides are given and an angle. We try to find one more angle. The angle we find is less than 180 degrees, obviously, for a simple reason, because, of course, all angles must add up to 180, all interior angles. Therefore, it must be less than 180. And because it's less than 180, and because sine is positive in the first and second quadrant, you subtract that from 180, and that gives you the second angle. Now, if the second angle added to the given angle is larger than 180, the second angle doesn't work. But if it's smaller than that, then we have two sets of solutions, as it is the case here. When we go through the process, one of the angles is 49.9 degrees. Then if we subtract this from 180, it results in 130.1 degrees. And the given angle is 35 degrees, 35 and 130.1. The sum is less than 180, therefore it's possible to find the third angle for that. So we have two sets of solutions, which means we have two different triangles. And we went through the process, very straightforward, using obviously the sine laws to finish the job. And it looks something like this. We have two triangles, both of which one side is 6, as you can see. In essence, this angle and this angle are supplementary. They add up to 180. They add up to 180, and that's what happens to this angle. B1 and B2 are supplementary. Finally, when we work this out in this example, we end up with sine being larger than 1. Sine is between -1 and 1, and therefore there is no solution. And this is where we don't have any triangles. Okay? So that's why it's called the ambiguous case. This is the last one we did. We went through the process. We found sine A to be larger than 1, and that's why there is no solutions. Again, the reason is because this is larger than 1 and it can't be. Sine can only be between -1 and 1, the value for any sine. All right, let's move on to applications, and I'm going to ask students to help out. Could somebody read this for us, please? Go ahead. I'm hoping that everybody helps. Yes, go ahead, please.
A surveyor takes two sightings of the peak of a mountain at a distance 900 meters apart on a direct line to the mountain. The observations are at angles of elevation of 47 degrees and 35 degrees, respectively. If the transit is 2 meters high, what is the height of the mountain?
Perfect, thanks. So we have the transit here. The angle of elevation, 35 degrees. We move it closer by 900 meters. We have a different angle of elevation, 47 degrees. We want to find the height. So we're going to do the drawing of this so it becomes clear. So this is exactly what we have here. So this is 2 meters. Okay, so this is this line, 35 degrees, 45 degrees. Okay, this distance is B. From the bottom to the top is H. Okay, first and foremost, H is B plus 2. We are interested in finding H, the height of the mountain, which is B plus 2. So all we have to do, find B. So we are going to call this A. This is C, obviously. This one or this one is a B. And we are going to find the missing angles. I hope you realize this is a line, a straight angle, 180 degrees. So we can find this angle to be 180 minus 47 degrees. So take a look at this one. C, the angle C with 47 degrees must be 180. So we can find the angle C. Remember, H is B plus 2. We are trying to find B. And to find B, we need one other side. For example, maybe this side or this side or this side in order to get to B. One of those sides. So we got this angle. If this is 130 degrees, if you look at this one, this is 35. This is C, which is 133 degrees. This little one, A, this one is the sum of 35 and 133 subtracted from 180. In other words, this angle, and this angle must add up to 180. So this is 133 degrees. So A and C and 35 degrees is 180 degrees. So A and C and 35. We know C to be 133 plus 35 is 168 subtracted from 180, and you get A to be 12 degrees. So again, just to make sure. So we are going to replace C with 133 degrees, everybody. So we have this angle, and so forth. So what happens in this triangle, we can use the sine law. So this is 12 degrees, everybody. This is 12 degrees. So why did we need that? Because the opposite side is 900. So we need this angle. So sine A over A, sine of 12 degrees over 900 is sine of this side 133 degrees over what we are looking for, this big side lowercase c. Okay, lowercase c. And therefore, c is the product of these two divided by sine of 12. Put it into a calculator, use a bunch of decimals, rounded accordingly, you end up with 3,165.86, and you use the same units, meters, because it was 900 meters. Now, in the big one, sine is the opposite over the hypotenuse. So sine of 35 degrees in the big one is a B over C. B over C. And C is found to be this number, right? Plug in. B is the product of C, which is this number times sine of 35. Using a calculator will result in 1,815.86 meters, roughly. So what do we have? We have the value of B. Add 2, you have the height. Add 2, and you have the height. We are going to move on. So 1818, roughly. Class, we are changing this to 1816 and to 1818. Remember, these are all approximations. So it depends how they want you to report that with however many decimals. So we took this and changed it to a whole number. You shouldn't do that unless you're asked to do so, okay? Could somebody read this question, please?
Coast Guard Station Zulu is located 120 miles due west of Station X-ray. A ship at sea sends an SOS saved a ship call that's received by each station. The call to Station Zulu indicates that the location of the ship is 40 degrees east of north, bearing N 40 degrees east. And call to X-ray indicate that the ship is 30 degrees west of north, bearing N 30 degrees west. How far is each station from the ship?
Excellent. So they received the signal. We have a couple of stations. According to one of them, the Zulu station, the bearing is north 40 degrees east. According to the other station, X-ray, it's north 30 degrees this time west. So we're going to triangulate to figure out what's going on. And we know the two stations have a distance of 120 miles. So we want to see how far each station is. In other words, we want this distance as well as this distance. So first, understanding the drawing, that is extremely helpful. So this is 50. This is 60. We can easily find this. By the way, 40 and 30 are given. Because this makes a 90-degree angle, 90 minus 40 makes this 4. So maybe they don't give you that, but you have to figure out this is 50, 90 minus 40. Maybe they don't give you that. You should figure out 90 minus 30 is 60. Now I have this one, I have this one. All I have to do, add them up, subtract from 180, and I get C. So 180 in this one. 180 minus the sum of the other two minus 110 gives me 70 degrees. So I have this angle now. I have all the angles. And I have one side. That's all I need. I use the sine law and I find the other two sides. That's all there is to it. So if I want to write this for all of them, and I do that, sine of 50 over A is equal to sine of 60 over B is equal to sine of 70 over 120. So we must use this with the first one to find A, with the second one to find B. So if we use these two only, then A is the product of these two, 120 times sine 50 divided by sine 7. So the product, the cross product for this one and this one will result in A being 120 times sine 50 over sine 7. That's for A. And of course, A means the distance for X-ray. A is the distance the ship has from X-ray station. Plug it into a calculator. maybe I write this quickly so everybody can see that I'm using sine 50 over A equals sine 70 over 120. Cross product gives me this. Calculator gives me 97.82. And I use the same units. This was 120 miles, so the units are miles. Okay, everybody. For Zulu, I'm going to use this too. If I use these two and do the cross product, everybody, B times sine 70 is 120 times sine 60, so 100 times 120 times sine 60 divided by sine 70 is B, and B is the distance from the Zulu station. So this one. I hope everybody is clear on that. Maybe I quickly write this. So sine of 60 over B equals sine of 70 over 120. And the cross product results in this. You put it into a calculator, you get 110.59 miles. So, in short, this distance A, almost 98 miles. This distance B, almost 111 miles. This is more. If a helicopter capable of flying 200 miles per hour is dispatched from the nearest station to the ship, how long will it take to reach the ship? Remember, D equals RT. Let me just write that. Class, I hope everybody remembers this, that D equals RT. So T is D over R, meaning distance over R. Distance is what? This one or this one. Nearest station would be this one. So we can use any of them. But since we are definitely going to go faster, we want to go with the nearest station, 97.82. So this is our distance. How fast can we go? 200 miles per hour. So T is D over R, or more specifically in this case, A over R. Why A? Because A is the nearest station, gives us the nearest station X-ray. A is smaller than B. And it's almost half an hour. It's 0.42 hours, which makes it about 29 minutes. Basically, you multiply by 60 minutes. This one I gotta fix it, class. 0.49. I was thinking 0.42 is wrong. It's almost half an hour. 0.489, so forth. Could somebody read this one, please? Go ahead.
The highest bridge in the world is the bridge over the Royal Gorge of the Arkansas River in Colorado. Sightings to the same point at water level directly under the bridge are taken from each side of the 880-foot long bridge, as indicated in the figure. How high H is the bridge?
Excellent. All right, so here's the setting. We have this distance, we have these two angles. We are going to call this distance x. We're going to draw this triangle. It makes it easier to follow it here, class. This distance, we call this A, we call this B. This distance of AB is 880 feet. This angle A is given at 69.2 degrees. This angle is given at 65.5 degrees. We called this distance x. How high is the bridge? We are interested in finding the h. So if we call this D, in this triangle ACD, meaning this one, this one, okay. Sine of 69.2 degrees is the opposite h over the hypotenuse x, and therefore h is the product of these two, the cross product. H is x times sine of 69.2 degrees. All we have to do, find x, and we are done. So how do we find x? If you go to get to the big one, ABC, the triangle ABC, we have two angles, which means we can find the third one, right? So in the triangle ABC, we have almost everything. We have two angles. Add them up, subtract it from 180, and it gives you angle C. (45.3 degrees). Again, the big one. We have two angles. We add them up, we subtract from 180, we get the third one. Why do we do that? We have this angle, we have the opposite side. We have this angle, we can find the opposite side using the sine law. Therefore, sine of this side, sine of B, 65.59 over the missing x, is the sine of a C that we found, the sine of 45.3 over AB, and we know it to be 880 feet. Okay, so one more time. Sine of 65.5 degrees is opposite the x. Sine of a C, 45.3 degrees, is opposite the AB, 880. Therefore, the cross product gives us the product of these two divided by this one. Okay, cross product. X is 880 times 60, sine of 65.5 degrees over the sine of 45.3 degrees. And you put it into a calculator. So X or AC. As this value from the calculator, we get 1,126.57 feet. Replace the X here. Replace the X here. and that gives you the height, or CD. So replace it here, right? Using a calculator, find sine of 69.2 degrees, multiplied by the number, and you get 1053.15 feet. So that would be the height. As far as the number of decimals, most likely they will ask you. If they don't, you want to carry many decimals. Don't take a chance. Okay, always many decimals, just to be on the safe side. So pretty straightforward, I hope. Here's the last question. Could somebody read this, please? Last question. Go ahead.
The navigator of a ship at seaports sea spots two lighthouses that she knows to be 3 miles apart along a straight seashore. She determines that the angles formed between two line-of-sight observations of the lighthouses and the line from the ship directly to shore are 15 degrees and 35 degrees. How far is the ship from lighthouse P? And how far is the ship from lighthouse Q?
Perfect. So if we are looking at this drawing, this setting, okay, so the line of observation results in a 15-degree angles for P, 35 degrees angle for Q, and the distance between P and Q is 3 miles. So let's put it here, okay? So this is P, this is Q. Now this one, we're going to give it a name R. This one is 15 degrees. This one is 35 degrees. PQ has a distance of 3 miles. And we want to see how far the ship is from P. Okay, so we want PR, and from Q, QR. So we want PR and QR. Understanding the question. So basically, in this triangle, all we have to do is use the sine law to get to the result. And to get to the sine law, we have one side. We are in good shape. We want to find all the angles. So I want to discuss how we get all the angles. So pay attention to that. Obviously, this is 90 degrees, so is this one, right? Let me, in fact, draw that. So this is a 90-degree angle. That means if this is 35, this must be what? 90 minus 35. This must be 55. If this is 15 degrees, what about this angle P? Must be 90 minus 15 degrees, 75. We have all the angles. We have this one because these two add up to 90 degrees. So you want to make a note of it. This angle plus this angle is 90. That's how we get the 55 degrees. This angle plus this angle is 90 degrees. That's why we get the 75 degrees. So this angle is 75 degrees. This one is 55, or the big one is the sum of 15 and 35, or 50 degrees. So or is the sum of 15 and 35, or 50 degrees. We have all the angles. We are practically done. We're going to write the sine law. So this angle is 50. Sine of 50 over 3 equals sine of 55 over PR. And that's because we want to find PR first. Fifteen and 35 is 50. Sine of 50 over PQ, which is 3, is the same as sine of 50 over sine of 55 over PR, which is missing, and we are looking for it. Cross product. PR is what? the product of these two, 3 sine 55 divided by sine of 50. Use a calculator. And it gives you 3.21 miles. So the distance from the ship to P, meaning PR, is 3.21 miles. To find QR, we are going again to use this one, which is known, sine of 75 degrees over QR. Sine of 75 degrees over QR. So we use the same one because this is known. Therefore, QR is the product of these two, 3 sine 75 divided by sine 50. 3 times sine of 75 divided by sine of 50. And again, we use a calculator. By the way, when you use a calculator, make sure it's in degree mode because we have a radian mode and degree mode. It's in the proper mode. And you get 3.78 miles. So the distance the ship has from the lighthouse P is 3.21 miles. From the lighthouse Q is 3.78 miles, a little bit more. How far is the ship from the shore? We want this distance. Okay, everybody. This distance, which is called D. Normally we call it H, but it doesn't matter. So what I want you to notice is that we are going to use one of those triangles. So I'm going to show you, let's see, this one. I'm going to use this one, everybody. P, R, with the distance D. So class, this is 75 degrees. This P, R, we found it to be 3.21 miles. And this is the distance D we want to find. And that, as I said, is 75 degrees. Why do we need that? Because we want to find D. Okay. So according to the sine law, obviously this is 90 degrees, right? Sine of 90 over 3.21 equals sine of 75 over D. So sine of 90 degrees over 3.21 is sine of 75 over D. Of course, sine of 90, everybody knows it to be 1. But in any event, D is the product of these two divided by sine 90. This we know it to be 1, but this one we put it into a calculator times 3.2. Division by 1 makes no difference. So that gives us the distance of 3.1 or 3.10 miles. The reason I put 10, if they ask for 2 decimals, you really want to be careful with that. Again, the number of decimals, it depends on you, everybody. If they don't ask, you want to go with many decimals. And if they ask, then you go to the next one to do the proper rounding.